Well, hello. I thought I'd make a part 2 video to my fridge problems fixed video. That was the first one I made about a year ago. Brought on by the fridge not working, obviously, when I was towing my Caravan, which I just acquired. Having addressed that and having fixed the problem so the fridge now works perfectly when towing on DC, as covered off in that video, it introduced a number of new issues. Once that fridge is working and you're left home with your fridge already at 3 degrees, or 4 degrees, whatever it is, 3 or 4 degrees, and it's unplugged from the power, you hook it up to the car and off you go, and the fridge is now operational. The three-way fridge, the Dometic in my case, to RM2453 or 254, whatever it is, in my case, that three-way fridge will continue to cool down because the thermostat fitted to those fridges only works on 240 volt mains and on gas. But when it's on DC, on 12 volts DC, it doesn't operate. Now, I think maybe that's a function of, it's been around for a fair while, that fridge, and I think they were aware that possibly you weren't getting enough power in the van to successfully run the fridge, and it was never going to get very cold. It would just maintain. Because I think in years gone by, we didn't have DC to DC converters to maintain, probably didn't have AGM batteries even way back. People were fitting standard cranking batteries, so they were only 13 volts or so, if they were lucky, and if they were powered, as most of the vans were designed to do, powered directly from the Anderson plug, not from a battery in the Caravan. That source of power was 10 metres away via some inadequate amount of DC cabling, no doubt. So the fridge was never going to get much more than about 11 volts probably, maybe 12 or something with bigger cable. And the ultimate upshot of that was that the heater element was never going to achieve what it's supposed to do. So it wasn't going to freeze. But now in the days we live in today with DC to DC converters, which you should have, an AGM battery fitted to your van, and if your fridge is running from the battery in the van, and it can, that's no problem as long as you've got the DC to DC converter, then the fridge will freeze, and the food will freeze, and the beer, more of an issue, beer and wine will freeze, and you can't have that. You can't arrive at your destination with frozen beer and wine. So I had to address that problem because that's what was going to happen, and in fact did happen once I fixed the fridge. So, what to do? Well, a friend of mine told me about a microcomputer temperature controller which he'd bought and fitted to his fridge because he wanted to see if his fridge was working. That's all he wanted, was a digital display on the front of the fridge to tell him what temperature the fridge was at when he was running it on mains and gas, largely. He wasn't using it on 12 volts. He just wanted to know if it was working. Because a gas fridge, sometimes the pilot light will blow out. And I'd cover that off in the video. And so you don't know if that's gone out unless you're very diligent and you look at the little gas meter and you can see that the needle's dropped back. Other than that, you wouldn't have a clue that the thing's gone off. So it's nice to know it's working. It's also nice to know it's working when you're travelling, because when you pull up to have a coffee or something, you just glance in the window, you see the display, yep, it's all sweet. So that microcomputer temperature controller has a switched output and set parameters, and I'll cover that in this next video. And that allowed me to now control the fridge. And this provided a number of advantages if you do this, and probably if you fix your fridge you certainly should do it. I wanted to reduce the load on my alternator, and I wanted my batteries in my van to recover as quickly as possible. If the fridge is running all the time and consuming 16 or 17 amps, whatever it might be, but around about 15 or 16 amps, my charger is 25 amps, and that's what most of them are, and they shouldn't be any bigger than that because you shouldn't put more than about a fifth of the capacity of your battery back in from your charger. 100 amp battery, 20 amp charger sort of thing. So you don't want more than 25 amps probably is the max you want going into your battery. And you want that to recover as quickly as possible when you're driving between places, because you might have had an overcast day. Then you've used the appliances or the lights, television, etc., fans on overnight, your battery's discharged 10 or 15, 20%. You want that to recover. You might only drive 3 or 4 hours. You want that fully recovered by the time you get there, because it might be dark when you go, I don't know, who knows, could be raining still, could be whatever. You mightn't have any solar anyway, and it'd probably be okay if you're managing your power correctly, but it's nice to know that you can recover as quickly as possible. So battery pack recovery is sped up by your fridge not being a constant load. Your food's not, and beer and wine aren't frozen. Your alternator is working less, which is a good thing, because, well, I don't know in all vehicles, but a lot of vehicles have auxiliary batteries fitted to their tow vehicle. And again, in my case, I've got a DC converter up the front running that. Now, when that's fully discharged, I've been somewhere for 2 days, and the fridge in the back of the car with the drinks in it has just been running on that battery for a couple of days. It now is, 50% discharge, maybe more. So it's going to need its 25 amps, which is the DC to DC converter is going to put in 30 amps in normal ambient temperatures, so 25. It's got about a 5 amp overhead to run the DC to DC converter. 25 amps out, 30 amps in. When it was really hot, I was seeing 34 amps in because it gets less efficient as it heats up. So there's a lot of overheads with that. So if you're running both DC to DC converters, it's 50 amps constant load on your battery. So there's another facet to it. Reduce the load on your car, better fuel efficiency, and there is a significant impact. That's a lot of why we've got smart alternators, is about reducing the load of the alternator on the vehicle engine to improve fuel economy. So there are additional benefits you get out of putting a temperature controller onto your fridge when you're towing. Predominantly, it's to make sure the fridge doesn't freeze, and it maintains it at normal fridge temperatures. But the added benefit lowers the load on your car alternator, improves your fuel economy, and lets your battery in your Caravan recover more quickly, because it's 3/4 of the load, or 60 or 70% of the load, would be going into running the fridge if it didn't cut out. But when it cuts out, then all of that 25 amps is going to recover the battery. So that's the advantage. So let's have a look at this microcomputer temperature controller and how it's fitted to the fridge, and I'll put some other stuff up after that. Okay, let's have a look at this microcomputer temperature controller, as it's called. Comes from China, got it off eBay. And I was informed about this from a friend of mine who told me he'd fit it to his fridge to see what his fridge was doing. That's all he wanted it for. He just didn't know what temperature the fridge was internally. So I wanted it because now the fridge was working really well. It can freeze everything. So I fitted this. Now the added advantage of this panel meter is it has a 10 amp switched output that is controlled by the temperature. And you set the temperature you've got a set and enter button here. So we push set, and we can see that this is set to 3 degrees. And at 3 degrees, that's when the fridge cuts out. That's the cut out temperature. And so you've got to have a cut in temperature. So you can also set a differential by pushing and holding this button for 5 seconds. It goes into this code mode here. It's all written in Chinese too, it's terrible. You've got a number of codes. That P0 code lets you set it to hot or cold. P1 is the difference. So I've set it for 3 degrees differential. So you set that, and then you just push set, and it's done. So it's now set so that at 3 degrees the fridge switches this panel meter has a relay output, as I said, which breaks the DC power line that's feeding this switch here from this switch, which drives my relay that I fitted last year. So I've interrupted this now, so the DC supply to the relay at the back of the fridge is now activated through this. So I've got 12 volts feeding this switch. So when I select DC on here, in that mode there, it's on DC. I'm now feeding DC out of this switch to go to the to turn the element on, which feeds a relay. So this meter sits now between this switch and the relay downstairs, and it will interrupt it when the temperature required is reached. and that temperature, as I said, is set for 3 degrees with a 3-degree differential. So at 3 degrees it chops out, it will stop the heater element in the fridge, it will switch it off and says I don't need it anymore, I'll turn that off. And then there's a little bit of hysteresis in there, meaning it continues to cool down another perhaps half a degree or so as the element cools down. And then as it climbs back up, when it gets to 6 degrees, because we've set that for a 3-degree differential, at 6 degrees it will switch the element back on again. And then once again, when it gets back down to 3, it will switch it off. So this will cycle up and down as you would normally expect it to do. And indeed, as it does with the standard thermometer, thermostat, sorry, which is fitted to this fridge. It's over here. This button over here is the thermostat, which works on 240 volt mains power and works when gas is switched on. But it doesn't do anything on DC. DC runs continuously, so that's a problem once your fridge is working properly. So that's the story on this digital panometer. Anyway, that was a good idea, because the other advantage this has, I can see what the fridge is doing. So I know it should be sitting between 3 and 6 degrees at any time I look at it. And I can see it looking in the door. It's a nice big display. That's about nearly 20 millimeters high. Nice big display to see. And at a glance, looking in the window of the Caravan, I can see the fridge is running anytime, and I can see the temperature's right. Because when it's on gas, the only reason you know that it wasn't working is that this little red line has dropped back into the white, and it should be sitting in the green. And it can get blown out, the gas pilot light can get blown out by the wind. If you get very windy conditions, that can go off. And then again, at a glance, this will tell me, because this is cranked back up to whatever it is. So all that's on this thing is I just mounted this in here. There was a little gap in the housing behind here inside the chassis. I had to pull the fridge forward to do that, and you can get access from above. And there was a space just big enough for this to fit in. I missed it the first time. Didn't quite get it right because I thought this will cover it, but anyway, got it a little bit wrong and I had to move it down further. But that fits up in the top of that. So this is just a this piece here is just a dress, if you like, dress thing on the front of it. And so that was easy to. Why is that gone out of focus now? Bloody cameras! Drive your spare. Yeah, so this fits into this little space, as I said. The relay output from this controlled by the thermostat. The thermostat is mounted internally and monitors the air temperature. It's not very elaborate at all, so we'll open the fridge and have a look. And this is the oh, you can't even see it. Okay. Very constrained down here. So there's our thermostat dangling in there. It's simply, I drilled a hole in the roof up here, straight through there. There's nothing in the way, so just dropped the cable in here, ran it down the side, put a couple of little dobs of elastic on it, I think, and it just hangs in there and monitors the ambient air temperature inside the fridge. You could do something more elaborate than that. It could probably be glued to the wall or something, but hey, it works. Okay, in regard to the rating on this fridge, so somebody told me about this. This is a tropical rated fridge. It's got a 175 watt element. Now I believe that's bigger than the standard fridge, which is about 125 if it's not T rated. And you can see this climate class rating number here, so it says T. So that means good to 42 degrees. Well, thank God for that, because that's exactly. Okay, here's the original diagram of how the fridge was wired, and you can see it goes directly to an Anderson plug on the drawbar. So the fridge was fed directly from the vehicle alternator and battery at the front. Had nothing to do with the onboard battery. I think it was originally only charged via a mains charger on board. The second diagram
is what I did last year, where I added a high current relay between the fuel source selector switch. So when it was on DC, the selector switch only had to enable the 30 amp relay, and that provided a high current, low resistance path directly to the fridge from the onboard battery. So that gave me the efficiency I needed. In this third diagram, you'll see that I've fitted the microcomputer temperature controller, and it sits now between the fuel source selector switch, so that when DC is selected, that presents 12 volts permanently to the microcontroller. But the microcontroller now controls the 30 amp relay based on the temperature it's monitoring from the fridge, and only turns that relay on when and if it's needed. So here is the eBay listing. So just search up that title there, just copy and paste that into eBay, and that will come up because that's all I did from my purchase history. So that's the device. How cheap is that? $9. Ridiculous. Great value. Works fantastic. Here's a picture of the rear of the microcomputer temperature controller. As you can see, there's only 4 connections there. Power from the fridge, which is fed from the DC position of the fridge switch. And that's annotated by that little switch diagram behind the first 2 screws in the center of the board. The output of that, so those first two contacts are closed when the fridge power is required. When the thermostat says that the fridge is over 6 degrees in this instance, that contact closes and joins the power source switch DC through to the 30 amp relay, activates the relay, which then enables the high current path through between the battery and the fridge. So that's the first 2 screws. Next screw goes to common ground or chassis ground or whatever ground is available in the van. But you don't want this to you want this to pick up a real earth. If you've got a Caravan where you hit the switch and it turns everything off, well, I suppose you could do it, doesn't matter. All right. It's just you'll have no display on the fridge, and maybe that doesn't matter when you're away from the van. And then the last one on the right-hand side is that's permanent 12-volt supply. So your display is always on, because this thing will display temperature regardless of whether you're on mains power or on gas. The relay will still activate and do things, but it doesn't do anything because the DC position is not selected on the fridge. So you'll have an illuminated display telling you the fridge temperature at any time, regardless of what the source power is. It's only going to be doing something when the source is DC and it's controlling the DC heater element on the fridge. That's the only time. But the rest of the time it will display the accurate fridge temperature. So it's still handy that way.
There you go, folks. That's the ins and outs of the microcomputer temperature controller, how it's fitted, what it does, how it works. So I hope that helps some of us, or some of you. Certainly helped me. So don't forget to hit like down the bottom there if you enjoyed the video, and by all means subscribe if what I'm putting up is of interest to you. Thanks for watching.